Hi everyone and welcome to the internet. What we're going to be doing in today's physics lesson is having a look at Newton's second law. So first thing I'd like you to do then is have a go answering these two questions based on our previous lesson. So I'll just give you a couple of minutes to answer those in your books. Okay, let's double check those answers then. So for question 1, Newton's first law states an object will continue to stay at rest or move with uniform velocity unless a force acts on it. So give yourself a tick if you got that right. If you didn't, I'd suggest you write it down now so you do know what Newton's first law states. Our second question, draw a free body diagram for a feather falling at a steady speed. Hopefully we've got a diagram like the one at the bottom of your screen there. So we represent our feather with either a circle or a box, and then the two arrows, one pointing up and one pointing down, are equal lengths. Then we've labelled it with the one pointing up as the force of the air on the feather and the one pointing down the force of the earth on the feather. So make sure you've got those right. Obviously give yourself a tick if you did. If not, then write the correct answers in. I'll leave these up just for about 30 more seconds so you can finish off. Okay, so next question for you to have a go answering in your book then. How does the frog move? So see if you can answer that in your books. I'm just going to give you about a minute and a half to do that. Hopefully what we said here is that the back legs of the frog are going to exert a force, which then creates a resultant force, making the frog move forwards or up, whichever direction it happened to be going in. So when it comes to thinking about what's actually happening, then what we're really talking about are resultant forces. Now, when we're referring to a resultant force, this can change the speed of an object, It can change the direction of motion of an object, or it could change both the speed and the direction of motion of an object. So make sure that you've got those three things the resultant force can do to an object written down in your book. And then what I'd like you to do is see if you can finish off that definition of acceleration. So acceleration is a change in fill in the blank for me. So I'll leave this up for a couple of minutes so you can get these points written down and have a go at finishing off that definition for me. So hopefully we finished off our definition of acceleration with saying that acceleration is a change in speed or direction. So make sure you do remember that very important point, that when we're talking about acceleration, this isn't just the speed of an object that's changing, it could be the direction in which it's traveling and that changes. So acceleration is a change in speed or direction. Make sure that's written down in your book. Next thing I'd like you to have a go at doing then in your book is to draw me a free body diagram. What I'd like to do is draw a free body diagram for a tennis ball that's accelerating towards the ground. So have a go at doing that. I'll just give you a little over a minute to get that done for me. Okay, so to draw a free body diagram of our tennis ball accelerating towards the ground, then we need to start off, same as always, by creating our box or dot in the centre to represent our object. So all we've done is we've just put our box or dot in the middle to represent our object. Now, what we need to think about are the size of the forces here. So what we've been asked to do is draw a tennis ball accelerating towards the ground. Now, if something's accelerating towards the ground, it means that the downward force must be larger than the upward force. So we need to draw a bigger arrow going down. It's far better to do this with a ruler, obviously, than we've got going up. So what we see is, unlike in our previous free body diagrams with Newton's first law, where we were talking about the fact that those forces are the same as one another, this time, because it's accelerating towards the ground, the arrow pointing down towards the ground must be longer than the one pointing up, because remember, the length of the arrow tells us the size of the force. Then all we need to do is actually label these. So downwards we've got the force of the Earth on the ball. And our upward one here, that's going to be the force of the air on the tennis ball. So force of air on the ball. So what we've got there is our free body diagram. Because this arrow is longer than this arrow, it's going to be accelerating down towards the ground. Okay, so in your books, another question for you to have a go answering here. Is an object that orbits the Earth accelerating? So think about that, yes or no, and then explain your answer for me. 1 minute, have a go answering it in your book. So the answer to that question is yes, it is accelerating if the object is orbiting Earth. The reason for that is, even if its speed is constant, then its direction will be changing. Because in order to orbit the Earth, it's obviously going around us, and therefore its direction is constantly changing. Now, what we're looking at here, because we've got things that are related to one another, then we can put that together into another formula. So this is one of the formulas you've got to memorize for your physics exam. So force in newtons is the mass in kilograms times the acceleration in meters per second squared. Now, things to look out for in this is making sure the mass is in kilograms. If they give it to you in grams, obviously divide by 1,000 to get it into the kilograms. So what I'd like you to do is write down the formula at the top as it is in your books. So you've got that record, highlight it, put it in a box, do something to make it stand out so you know you've got to learn it. It's also good at this point to add it to your flashcard pile that hopefully you're generating for these physics formulas. Then what I want you to do is rearrange that equation to show how we could calculate the mass. So I'll leave this on the screen for you for a minute and rearrange it to show how we calculate mass, and write that in your books for me. Now, if you're not very keen on mathematically rearranging any of these formulas, then you can just use the triangle method. So if we put that into a triangle, then what we need is mass and acceleration at the bottom because they're being multiplied, and that means force sits at the top. So if we wanted to calculate the mass, we cover up mass, and that gives us force divided by acceleration. So again, I'd suggest you write the triangle into your books so you've got that quick reference on how we could rearrange it to find any of those particular aspects. So we've introduced a formula, which means it's time to have a look to see how we use it. So here's a worked example for us. A lorry has a mass of 8,000 kilograms. What resultant force is needed to produce an acceleration of 2 meters per second squared? So let's have a look at how we can work out one of these calculation questions. So a lorry has a mass of 8,000 kilograms. What resultant force is needed to produce an acceleration of 2 meters per second squared? So what we actually need to do then is, as always with our questions, that our calculation is, as we read it, we're going to underline, circle or highlight the key bits of information. So what we've got is a mass of 8,000 kilograms, an acceleration of 2 meters per second, and we're going to be calculating the force. So what we're then going to do then is we're going to write down the formula that we know. So force is our mass times acceleration, so F equals ma. Then what we need to do is substitute in. So mass, first of all, is 8,000 and it's already in kilograms, so we don't need to do any conversions. So it's going to be 8,000 times by our acceleration, which is 2 meters per second squared. Now you can use a calculator, of course. Hopefully you can do that in your head anyway. So that's going to give us an answer of 16,000, and then the units, because it's force, that will be in newtons. Okay, we've seen our example. Now it's your turn. So 3 questions. Have a go at answering those in your books for me. Don't forget you can use a calculator. Okay, let's mark those answers then. So for our first one, to calculate, force is mass times acceleration. So substitute in, our mass was 2,000, the acceleration was 5, 2,000 times 5 gives us 10,000 newtons. Give yourself a tick if you got it right. For number 2, it's going to be 60 times 4, which gives us 240 newtons. Tick that one if you got it right. And then finally, our third one is going to be 1 times 3, which gives us a force of 3 newtons. Tick that one if you got it right. Add them up, give yourself a score out of 3. So, slightly more complex question for you to have a go at here. Calculate the acceleration of a car if the force due to the engine is 1000 newtons and drag force and friction equals 600 newtons. The mass of the car is 800 kilograms. So see if you can work out the answer to this one for me and write your answers in your books. First thing we do, as always, is underline, circle or highlight the key information in our question, which you can see I've done there. Now, what we need to do is calculate the acceleration. So we know force is mass times acceleration, which means acceleration is force divided by mass. So write down the actual equation you're going to use first of all. Then what we need to do is substitute in. But in our force, we've actually got two opposing forces. We've got the force of the engine, which is going to be going in one direction, and drag and friction going in the opposite direction. So what we need to do is work out the resultant force first of all. So to do that, it's 1000 minus 600 because we've got to take them away because they're going in opposite directions. And then we divide that by the mass, which is 800. And that gives us an answer of 0.5 meters per second squared. So give yourself a tick if you got it right. Now, what we need to understand is how to carry out an investigation into this. So if we wanted to show that acceleration is proportional to force and mass using the experiment, how could we do it? So I'm just going to give you a couple of minutes to write down a list of equipment and a method on how you think we could investigate this. First thing we've got is our list of equipment. So we need a trolley, masses, a pulley, some string, and light gates attached to a data logger. So this is our list of equipment, and you need to write this down because this is one of those potential assessed practicals they could ask you about on the exam. So write down the list of equipment for me first of all. In terms of the method, so how we're going to carry this out, then I've given you a little diagram at the bottom so you can see our trolley with a bit of string goes over the pulley and attached onto some masses. Now what we're going to do then is attach different masses onto the end of the bit of string. We're then going to let the mass drop to the floor and we're going to record the acceleration of our trolley using some light gates. So what we'll do is we'll have a bit of card sticking up in our trolley, and as it passes through the light gate, then it's going to work out the speed in that first one, and then as it passes through the second light gate, it works out the speed at the second. And from that, we can get the acceleration. And by we can get it, I mean the data logger just tells us, because they're quite good bits of kit, really. What we can obviously do here is we can change the mass, but any mass removed from the string must be added to the trolley. Otherwise, we're changing the overall mass. So hopefully you've got an idea of how this works. There's some really good videos on YouTube. If you search force is mass times acceleration or Newton's second law required practical, they'll take you through the whole thing. So, penultimate question of today, is an object moving at a constant speed in a circle accelerating? Why and how? Add those to your answer. So write those into your book. I'm just going to give you a little over a minute to get that done. So the answer to that is that yes, it is accelerating. The reason that an object moving at a constant speed in a circle is accelerating is because the direction or the velocity is changing. Remember, velocity is the speed in a given direction. So if the direction changes, the velocity also changes. Now, for that to happen, a force directed towards the center of the circle is acting on that object. So make sure you've got those answers written down if you haven't already got those correct. Final thing for today then is have a go at our plenary questions. So those of you with a target grade up to a grade 5, 2 columns on the left. Those of you with a target grade over a grade 5, it's the 2 columns on the right. So I'll leave these on the screen for about 3 minutes, but you can always pause the video if you need more time. As always, you can find the answers to the plenary over on my website, scienceright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.